Okay, so for this example, we will now solve the maximum length of stroke for crank and slotted lever mechanism. Oh, so we have the given lengths of our links. So AB, BC, AD, and DQ. And we also have the distance between B and the slider. So this should be the horizontal distance, no? So BC rotates with a uniform angular speed. So how do we determine the length of stroke for this quick return mechanism? So as you can imagine, what does crank and slotted lever look like? No? So crank slotted lever looks like you have B here, okay, right, B here, and then you have point A here. So these are the frames, no? Okay, so you have the frames here, and then for A you have a long, no? Long length, and then you have the slider here for this link C, and then this point D here has another link here for point E. Sorry, actually I think Q is this one. So we want to find the maximum length of stroke. So as you can imagine, this will rotate counterclockwise. Okay. And then as you can see, it will, no? So this Q here can rotate in this direction. Sorry, it can reciprocate in this direction and this direction. As long as this is your, I mean, you have a slider here that restrains this motion here. So this is your line of stroke. Now, if you want to find the maximum length of stroke, we want to first find what are the angles, no? Okay? And what is the position as well of your or what are the extreme positions um of your QRR? So for crank and slotted lever mechanism, the best position would be when AD is tangent, no? So if AD is tangent to BC. So in a real case, no, you can imagine this will be the position where it is tangent, and then as you can see, this will be the position, the first extreme position of your crank and slotted lever mechanism. Again, remember that for crank and slotted mechanism, the extreme position is when AD, so this AD right here, so D prime here, or actually I use double prime, and then you have Q double prime. So if A double prime D is perpendicular to BC, so this will be your slider. Anyways, this will be, and then the other extreme position will also be the perpendicular, perpendicular position right here. Okay, so this will be until this. So you have this D prime, and then you have still the Q. So this will be your Q prime, and this will be your other extreme position. So we want to find this distance right here, no? So this distance right here from here to here, actually from here to here, from their center lines. And sorry, it is not the best ratio, but I can extend this more. Yeah, sorry. I think this will be better. Yeah, this is a little bit better than the last time. So you have something like this. Sorry, this is not properly scaled, no? Okay, so actually we can find the QRR first because we can already determine this angle right here. So this will be your alpha right here, and this will be your beta. So you can already solve for QRR, which is we can solve for alpha, so I'll just use alpha, so 360 minus alpha over alpha. And the alpha right here, you can imagine, no? So you can draw a triangle here. As you can see here, something like this, no? So something like that. We have a triangle here. So we know that this is 90 degrees, and this is B, and this is C, and you have an angle, right? And what's left, no? So we also know the distance between AB. So AB is equal to 40, and BC is equal to 20. So you can determine this angle right here, which is the, well, actually, this is alpha over 2. Remember as well that this should be symmetrical, no? So this is symmetrical right here. So if you have this 2, this will be theta over 2. Yeah. So you can use trigonometric function. So you have cosine. So cosine alpha over 2 is equal to 20 over 4. So therefore, alpha here is equal to 2 r cosine 20 over 40. Yeah. So alpha here is 2 inverse cosine. Um, inverse cosine. You can just write here 1/2 since 20 over 40 is also 1/2. So you have 120 as your alpha. No? So therefore, we can say the QRR is equal to, so you have 360 minus 120. So 360 minus 120 all over 120. So the answer is 2. So QRR. So this is much better than just the crank and leave. The slider crank mechanism. For crank and slatted, the QRR is much better. No? So to find now the length here, no? So this length here, how do we find that, no? Okay. So this is quite challenging. So if you might ask, shouldn't this be straightened? No? So the answer is actually it can be straightened sometimes, but in most cases it will not be straight. No? So you have to create two triangles separately. So you can imagine this is the first triangle here, no? And then this is the other, sorry, not that one. This is the other triangle to find this length here, no? The length from here to here, no? So you can find this first. So I'll just notate this as x double prime for now. So we want to find x double prime. And we actually have these two right triangles right here. So we have this is AD, no? AD double prime. And then we have a given length here on the other side. No? Do we have? Okay, but anyways, so we know that this is 90 degrees and this is theta over 2. We can actually determine what angle is this. So the angle here is actually just, so you can calculate this. So this is 90, right? Oh, yes. We can actually calculate this one. So if this is 120, if this is 120, sorry, this is actually 60, sorry. This is 60 degrees because this is theta over 2. This is 90. Therefore, this should be 30 degrees. So we can say that this is 30 degrees right here. So we can solve for this length right here. I guess I'll just call this P, no? PD, no? So length PD, okay, is equal to, so I'll just use a sine law. So AD is determined, right? So AD is 80 centimeters, 80 here. And then that's it, no? So you have cosine, yeah, so you have 80 cosine 30 for PD, no? So this length right here, you can calculate this. You have 80 cosine 30, which is 69.28. 69, this should be sine pala, no? Sorry. This should be sine. My bad. So this should be sine 30. So this should be 40. Ayan. Okay? So in centimeters. So now, we already determined this portion right here. We want to now determine, this portion right here, no? We want to now determine this portion right here. So that portion right there is you have D double prime and this is Q double prime. And I'll just call this P. I guess I can use R. I, um, I guess I'll use R for now. It's okay for R. So the angle here is different, no? So this is not the same as that, the other one. So, but anyways, we know DQ, no? So DQ is 40 centimeters, okay? But we do not know this one. So we cannot solve this pala, no? So to determine this, we cannot solve this if we don't have an angle or this one. So we need to determine this one first. We can actually determine that one. We can actually determine this one. If we find the length of this one, okay, which is this, right? And plus, sorry, minus the total length here. So the total length here is actually, sorry, there's a lot of notation here, but this is from B to Q, or sorry, the distance from B to slider is 60, so this is 60 right here. From here to this B here, and then you have 40 from B to A, no? So 40 here for B to A, B to A. So you have 100, no? So 100 minus this PA length, you can determine the answer, no? So you can solve for PA as well. So that will be 80 cosine 30, which we have solved already, which is 69.28 centimeters. So the answer here should be 100 minus 69.28, which is equal to, so 100 minus 69.28. So this will be 30.72. So 30.72. Now we can use the Pythagorean theorem to find for RQ. So RQ here is equal to, you have the square root of 40 squared. So Pythagorean theorem, no? 30.72 squared. So RQ double prime, you have square root of 40 squared minus 30.72 squared. Yeah. So 25.62. 25.62 centimeters. So these are not the answers, no? So we can add this to. So if you add this to, basically this is your this is the total, no, of these two. So the x double prime is actually the total of you have PD, line PD and line RQ. So this is equal to 40 plus 25.62. That is 65.62. Okay, centimeters. So this is not yet the final answer for the stroke, no? We also want to determine this portion right here, no? So because we only determine this portion, which is x double prime, we want to also determine this portion right here, which is x prime. So for that one, we can solve that one still using so as you can imagine, we have here sorry, we have this thing right here, no, this triangle, and this will be B prime. No, it's not written, but this is B prime. You have Q prime. This is B prime, you know, and then you have A here. So the AD is determined, DQ is determined. So this is given, this is given. For oblique triangles, we need three values, no? We can solve for the angle here actually. So we know the angle here, right? The angle here. So the angle here, the total angle here is just what, no? This is 30 degrees. We already determined that this is 30 degrees. So therefore, this should be, let's say this is phi. This should be 30 minus phi. So that if you add this 2, this will be 30. Yeah. We also have another triangle here. So this connecting part right here. And this is what we are interested with. We can just hold this, which is this is basically x prime, no? So this portion right here, this other triangle, is what we're looking for, the x prime. So x prime here, and then this is phi. And then let's just say this is y, no? Or let's just say this is r. I'll just use R here for now, small r. And then this will be right triangle. So we can determine first this angle, or actually we can do the simultaneous equations to solve for the angle phi, to after that solve for x. So we can create equations here again using the cosine law for this oblique triangle. Okay, sorry guys. So this will be d prime q prime line, no? So this is the dq. And then sorry, I think I'll just write pala the dimensions, no? So dq is 40. So this is 40 right here. And then AD is 80 here. And then phi is actually, sorry, phi is still phi. That's all we got, no? So you have 40 squared is equal to 80 squared plus r squared minus 2 times 80 times r. And then cosine, you have 30 minus phi. Okay, so this is your first equation. For the second equation, you can use this. So this is a right triangle, so it is much simpler. You can just use in this case, you can just use the sine function, no? So you have sine phi is equal to x over r, no? So therefore, phi is equal to, or actually r, we can solve for r. So r is equal to x. Sorry, not x. Why did we use this? Oh, sorry. Actually, we should use this one pala, no? So we know that this is, anyways, this is x prime. We should use cosine pala, no? Since we also know this length right here, which is 100, right? So you have 60 plus 40, so this is 100. So you have cosine phi is equal to 100 over r. So this will be 100 over cosine phi. So using this, no, using this r is equal to 100 over cosine phi, you can substitute the values here, no? So you can solve this by substitution. You have 40 squared is equal to 80 squared plus you have 100 over cosine phi squared minus 20. Sorry, 2 times 80. And then you have 100 over cosine phi. And then you have cosine 30 minus phi. So solving for phi here, the angle in between, no? This one, you can calculate that to be, let's check out how do you solve this. So 40 squared, 80 squared, and then plus 100 over cosine x. 2 times 80, then 100 cosine x, cosine x times cosine alpha 30 minus x. So should solve. So the answer should be 8.18, no? So 8.18 is the angle. Okay. Now we can now solve the x prime, no? So the x prime here is what, no? So x prime is equal to, so using sine function, we already know the angle, or actually you can also use the Pythagorean theorem, but since the angle is already given, you can determine that x prime is um uh using tangent, no? This is 100 times tangent tangent 8.18. So this is equal to 100 tangent 8.18. So 14.37. So 14.37 centimeters. So I can't write the centimeters anymore. Therefore, going back now, so I'll just use this last space. So therefore, the stroke here is equal to x double prime plus x prime. That is equal to 65.62 plus 14.7. So let's add this to 65.62. That is equal to 79.99. So basically that is around 80, no? So this is about 80 centimeters. So this should be your maximum stroke. So that's all. But wait a minute, no? There's actually a shortcut to this, no? So you can do this long method if you forgot the formula, but the formula is actually much simpler than this. We can do an analysis and we can solve this in a much easier way. You can just use this formula basically because of this analysis. No? So how did we come to this? We can imagine again, I'll draw again this quick return mechanism. So we have this point A and B, and then okay, let's just imagine this is your I guess this one. Okay, so you have B, you have A, you have D here, and then you have, for example, this is Q, no? So let's say this is your maximum or the extreme positions here, or this, no? So you have P double prime and Q double prime, and then the other extreme position is this one. No? Hmm. So you have D prime and C prime and then Q prime. Okay. So what we're trying to find for is the distance between these two, no? And in the textbook, we usually notate this as R1 and R2. So basically the point R1 and R2. Okay. But if you can imagine, really, this should be the same as the length from D prime to D double prime, or D1 and D2, no? If you really look at the textbook. So basically, if we know that R1, the length of the stroke X max is just the length of the line R1 to R2, which is also the same as D prime to D2, D double prime. For the textbook, you can use D1 and D2, no? There are alternative notations to this. What we can do is we can actually have this, no? So we know that the quick return mechanism of the crank slotted is actually symmetric, no? So meaning whatever the length of this to this should be equal to the length of this to this because the angles here are equal, right? Right? No? So actually this is 90 minus pi over alpha over 2. Okay. And this is also 90 minus alpha over 2. So they are symmetrical. So we can just say this is point P here. No? Again, this length right here is the same as the length here. So what we can do is we can find the length PD and then multiply it by 2, no? Since they are symmetrical. So we can say that the S max is equal to the length PD, no? So either this D1 or D2, no? So we can just say D1 or D2, whatever. We can just say D. So we can use this formula if we know PD. But if we don't know the PD yet, well, we know that PD will be equal to what, no? So we can imagine again. So if this is P, this is D, no? And this is A. So we know that this is 90 minus alpha over 2. Therefore, this should be alpha over 2, right? Okay. So we can also write this in this form. So we know that this is a right triangle, right triangle. Therefore, we can use cosine. So to determine PD, which is this length here, which is also the same length as here. So we can say that cosine alpha over 2 is equal to the line PD, okay, over the line AD. No? So again, we can represent PD as AD cosine alpha over 2. So yeah, no, we can substitute this to this. So we can say that S max, no, the maximum uh, stroke length is AD cosine alpha over 2. Okay. So basically, if you find the alpha already, you can substitute this alpha and also the AD. So the final answer will still be 80. That's it. So I hope you learned something. Thank you guys.